In continuation of the previous video, we have to prove that Ex naught, this acts as a left identity for the product of path homotopy classes. So we have to prove Ex naught star F is homotopic to F. We have to define a mapping capital F which maps this portion to X naught, this portion to F, and the whole of upper line goes to F. So since this portion goes to F, this portion goes to F, we define mapping F to be a mapping which maps whole of this portion of the square to small f, and whole of this left portion that will map to X naught. So for any time t, for any point t here, we will find out firstly this point. Now we know if this is point t, that means the distance from this point to this point is t, and the rest of the distance is 1 minus t, because this is the 1 unit interval, 0 to 1. So here t is equal to 0, here t is equal to 1. So at any point t, this distance is t and the rest of it is 1 minus t. Now we know these two lines are parallel to each other. So if the ratio of this to this is t to 1 minus t, therefore the ratio of this to this is also 1t to 1 minus t. And now we know that here s is equal to 1 by 2 and here s is equal to 0. So we can find the value of s at this point, and that will be 1 minus t divided by 2. So at this point s is equal to 1 minus t divided by 2. So we will map this portion where s goes from 0 to 1 minus t by 2. We will map this portion of the whole line to the point x naught, and the rest of the portion, that is s goes from 1 minus t by 2 to 1, we will map it to small f. So we define capital F from I cross I to X by splitting S from 0 to 1 into two parts. One is S from 0 to 1 minus t by 2, and other is S from 1 minus t by 2 to 1. And what are the values given by what are the values of FST at this interval and this interval? And for computing those values, we will firstly map these intervals linearly to the interval 0, 1. So firstly, for Ex naught, for this path Ex naught, we map this interval 0 to 1 minus t by 2 to the interval 0, 1 linearly, because we know that domain of Ex naught, that is the closed interval 0, 1, and we have to define FST for this interval separately, means for the values of s which lies between 0 and 1 minus t by 2. So firstly we have to map this interval to the interval 0, 1 linearly, and that will be done like this. If s lies between 0 and 1 minus t by 2, then 2s lies between 0 and 1 minus t, which means 2s upon 1 minus t lies between 0 and 1. Similarly, for the mapping F, we can map this interval 1 minus t by 2 to 1 to the interval 0, 1 by whenever s lies between 1 minus t by 2 to 1, then 2s lies between 1 minus t to 2, then 2s plus t minus 1 lies between 0 to 2 plus t minus 1, which means 2s plus t minus 1 divided by t plus 1. This is lying between 0 and 1. So we define, now we know for any s lying in this interval, whenever s lies in this interval, now this is the point 2s plus t minus 1 divided by t plus 1 which lies in the interval 0 to 1. So for this s, this is the point which lies in 0 to 1, but because we have to map this interval to this interval for the mapping f, so we will map fst to f of this point on the interval 1 minus t by 2 to 1, and similarly ex naught at this point on the interval 0 to 1 minus t by 2. But we know ex naught is a constant path which maps every point to point x naught, so we can just write here x naught. So we define fst equals x naught whenever s lies in this interval, and f of this point 2s plus t minus 1 divided by t plus 1 whenever s lies in t 1 minus t by 2 to 1. So now we will prove that the mapping defined like this is well defined and continuous, and it satisfies all the properties to be a homotopy. So let us firstly prove this is well defined, because it has two different values at the point 1 minus t by 2. So at s is equal to 1 minus t by 2, the first value of the function is given by x naught and other value is given by f of this. So we calculate this, f of 2s minus t plus 1 divided by t plus 1. 2s plus t minus 1. So at s is equal to 1 minus t by 2, if we put s is equal to 1 minus t by 2, it will become f of 0, and f of 0 is x naught. We know x naught is the starting point of the path f. So the other value is already x naught, so this is well defined. Similarly, f is continuous by pasting lemma. Because the domain of f, which is I cross I, this is split into two parts, and that two parts are these two portions. I cross I is divided into these two portions, one is this and other is this. So I cross I is divided into these two portions, and these two portions are closed in I cross I, and capital F restricted to this portion, that is just equal to x naught, and restricted to this portion, that is given by small f, like this definition, and small f is also continuous. So both the restrictions are continuous mappings, and both the areas, they are closed in whole of the I cross I. So by pasting lemma, this mapping is continuous. And next we have to calculate f at s0. So f at s0. Now because we are taking t is equal to 0, so again we put here fs0 is equal to x naught whenever s belongs to 0 to 1 minus 0 by 2, that is 1 by 2. And when we put t is equal to 0 here, then s from 1 by 2 to 1, it is given by f of 2s minus 1. So when we put t is equal to 0, from the definition fs0 is x naught for the interval 0 to 1 by 2, and f of 2s minus 1 for the interval 1 by 2 to 1. And by definition it is just ex naught star f at point s, because ex naught is a constant path. So ex naught at 2s is x naught, and f of 2s minus 1 on the rest of half of the interval. Similarly, f of s1, now we put t is equal to 1 in this definition. When we put t is equal to 1, so this becomes just point 0. So at point 0 or at s is equal to 0, it is x naught, and on the interval 0 to 1, it will be given by f of s. But we know f of 0 is already x naught, so the whole function can be written as just f of s. So f of s1, that is ex naught star f at s, and f of s1, that is f of s for all of s in I, and moreover f0t. Now we are taking s is equal to 0, and s is equal to 0 belongs to this interval, so the value is given by just x naught. So this is x naught. Similarly, f of 1t, now we are taking s is equal to 1, and the value is given by this interval, that means the value is given by this, f of this. So f of, now s is equal to 1 here, f of 2s plus t minus 1. So when we put s is equal to 1, it will be just t plus 1 divided by t plus 1. So it is f of 1, and f of 1 is x1. So now we have proved that there is a continuous mapping f such that fs0 is ex naught star f at s, fx1 is fs, f0t is x naught, f1t is x1, which means ex naught star f is homotopic to f. So or in other words, we can say that ex naught star f, this is equal to f. That means for the product of homotopy classes, there exists a left identity. There exists a homotopy class, the homotopy class of the path ex naught, which is a constant path taking all the interval 0 to 1 to the point x naught. This will be the left identity for homotopy classes of paths starting at point x naught. Similarly, we can prove the other part, that the path ex1, that will give the right identity for the same operation.